Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning first of all? Vista's Learning is an online education platform where we strive to deliver quality education for all. So we'll be continuing from the previous session wherever we had stopped in class 12th. And in the previous class, I think we had stopped in the introduction of matrices. So let us just have a very quick recap about that and we'll be continuing with today's topic in today's session. All right. So in the recap, what we saw what is matrix, correct? What is matrix, students? Just a recap, what we did in the previous session. Matrix is nothing but a rectangular array of numbers, okay, which are arranged in rows and columns. So what is the standard way of representing a matrix? So matrix A, okay, with the square bracket closed, 2 cross 2 is written as, the standard way or the standard form of a matrix is A11, A12, A21 and A22. So this is the standard way of representing a matrix. Now what are these A11, A12, A21 and A22? We have seen in the previous class. Yes, these are the entries or the elements of a matrix. So what is the standard form of these entries in a matrix? The standard form of the entries in the matrix is given by A, I, J. Okay, where I represents the row and J represents the column. So for example, A21, element belonging to the second row, first column, correct? A22, element belonging to the second row, second column, like that. All right. Next, what did we see in the previous class? We saw the order of the matrix, which is nothing but 2 cross 2, correct? Because there are 2 rows and 2 columns. What is the standard way of representing an order? The standard way of representing an order is M cross N, where M is representing what? The number of rows in a matrix and N is representing the number of columns in a matrix. Apart from this, what did we see? We saw what is the meaning of principal diagonal. How do we define principal diagonal, students? Very simple. AII, correct? AII means this is called as a principal diagonal. See here, 1, 1 and 2, 2. Both are same, right? AII. Same row and same column. The elements which are in the same row and same column, all those elements are called as what? Principal diagonal. So principal diagonal is defined by AII. Next, what did we see, students? Trace of a matrix A is nothing but the summation of principal diagonal. Summation of principal diagonal means A11 plus A22 plus A33. So this will go until AII. Understand? So these are the things which we saw in the previous session. Apart from this, what did we see else? We saw the types of matrices, correct? What are the types of matrices? Square matrix, column matrix, row matrix, diagonal matrix, scalar matrix. So all those matrices, types of matrices we had seen in the previous class. In today's class, what we'll be seeing, or in today's session, what we'll be seeing is, we'll be starting with a new topic called as, so these are your learning outcomes. Equality of matrices, example on equality of matrices, operation on matrices. Okay, so this is what we are going to see in this session. So starting with the very first one, equality of matrices. So what is the meaning of equality of matrices? One of the important concepts in matrix. Okay, so if two matrices, matrix A given by Aij and matrix B given by Bij, are said to be equal if they are of the same order. Same order means what? M cross N. So A's order M cross N must be equal to the B's order M cross N. They must be equal to each other. For example, 2 cross 3 is equal to 2 cross 3. A also should be of what order, students? 2 cross 3. B also must be the order of 2 cross 3. So if they have the same order, then they are said to be equal. Another condition is there. Each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij for all I and j. So for example, see this. Matrix A we will write here. A11, A12, A21 and A22. Here we'll write the elements of the matrix A. So let us write -1, 0, 3, 7.2. So this is matrix A. Now let us take matrix B, students. So matrix B will take B equals B11, B12, B21 and B22. We'll write the elements here as well. Matrix B equals -1, 0, 3, 7.2. Now observe these both matrices, matrix A and matrix B. We'll see the order first. Order must be same. What is the order of matrix A? 2 cross 2. What is the order of matrix B? 2 cross 2. Orders are same. First condition is satisfied. What is the next condition, students? All elements of Aij must be equal to Bij for all I and j. -1 corresponding elements, -1, 0, 0, 3, 3, 7.2, 7.2. Corresponding elements are same, right? Means what? Corresponding elements. What is this element called as? A11. What is this element called as? B11. They both are equal to each other. A12 equal to B12, A21 equal to B21, A22 equal to B22. So the elements are also same in both matrix A and matrix B, which means, what can we tell? Order is same, elements are same, which means the matrix is an equal matrix. So how do we denote the equal matrix? Matrix A equal to matrix B. So this is called as equality of matrices. So 2 points to remember, which is on the screen here, of the same order and of the same element. If you have A equals 1, 2, 3, 4 and you have B equals 2, 1, 3, 4. Elements are same. Are the corresponding elements same? That is what we have to see. 1 we have here, but here we have 2. Corresponding elements are not same. Therefore, we can write A is not equal to B. Okay, students. Order must be same. Corresponding elements must be same. Then only we can term that matrix as 2 matrices are equal or equality of matrices. So one small example on this. Equality of matrices. So this is the example from NCERT only. So 2AB, A minus B, 5C minus D, 4C plus 3D is equal to. So they are telling in the question, this matrix is equal to this matrix. So what should we find here? Here we have to find the value of A, B, C, D from the equation. So from this equation we have to find out what is A, B, C and D. So whenever the 2 matrices are equal, okay, what we can do is we can equate the corresponding elements of both the matrices. So here we'll start doing this. 2A plus B is equal to what, students? 4. Next, A minus 2B is equal to -3. 5C minus D is equal to 11 and 4C plus 3D is equal to 24. Equality of matrices, right? Both the elements are equal. See in the previous one, -1 is equal to -1, 0 is equal to 0. So similarly, in this example, what we have, 2A plus B equals to 4, A minus 2B equals -3 and so on. So now we have to solve this. So once we solve this, we'll be able to get the values of A, B, C and D. So how do we solve this, students? By simultaneous equations. Okay. So let us solve this first. 2A plus B, A minus 2B. Okay. Add both the matrices. What will you be getting? Or subtract both the matrices. You will be getting equation, sorry, not matrices. 2A plus B minus A plus 2B is equal to 4. Minus of minus is nothing but plus 3. Okay. 2A minus A is A. So this will become plus 3B, which is equal to 7. We got another equation. Okay. Similarly, you can also solve these both matrices, so solve these both equations. So here we'll do by elimination method will do. So here we will try multiply this with 4 and multiply this with 5. Okay. So what can be done here? 20C minus 4D is equal to 44. And this will be 20C plus 15D is equal to 120. Okay, so change the signs, minus, minus and minus. So these both will get cancelled. Minus 15 minus 4, this will become minus 19d, which is equal to minus 120 minus 120 plus 44. So this will give us 24 means 76. Okay, and 19 fours are, so what is 19 fours? 19 into 4, 36, 4 ones are 4, 76. So minus 76, minus minus cancel, 19 ones are, 19 fours are, therefore d will be equal to 4. See students, by using the simultaneous equations, by elimination method, what we got? The value of d we got. Now just back substitute this value of d in any one of these equations. Okay, you will be getting the value of c. So similarly here, we tried subtracting these both equations directly. We were unable to get an answer. We got another equation instead. So same elimination method must be applied here as well. You will be getting the values of a and b as well. Okay, now we'll find out c first. D is equal to 4 we got. If d is equal to 4, what is c? So 5c minus 4 is equal to 11. 5c is equal to 15. C will be equal to 3. So C we got, D we got. These both are done. Okay, same thing again here for the first set of equations. This we will multiply by 2. Okay, this method was not possible. Okay, we did not get the answer here. We got another equation instead. Okay, so we'll simultaneous equation again, multiply the second one with 2. We'll be getting the values of A and B. Okay, so we'll start solving that. So this will become 2a plus b is equal to 4. And this we will be getting 2a minus 4b is equal to minus 6. Change the signs. So this will become minus, plus and plus. This will get cancelled. 5b is equal to 10. 5 ones are, 5 twos are. Therefore b is equal to 2. Once we get b is equal to 2, back substitute it here. Okay, 2a plus b is equal to 4. 2a plus b is nothing but 2 is equal to 4. So 2a is equal to 2. 2 cancel. Therefore a is equal to 1. So what we have done here, students? So two matrices were given to us. On the left hand side we had the numbers, and on the right hand side we had the variables. Correct? So we equated the matrix by equality of matrices, solved those simultaneously, got the values of A is 1, B is 2, C is 3, D is 4. So therefore 1, 2, 3 and 4. Understanding equality of matrices. We have to equate the corresponding elements of both the matrices, solve them and get the answers of A, B, C and D. So this is one of the example of equality of matrices. Moving on to the next one. The next topic here is operations on matrices. So addition of matrices, difference of matrices, multiplication of a matrix by a scalar and multiplication of matrices. These both are same, students. Okay, these both are not same, similar. I'll tell you how. So addition of matrices, we'll take one example. So addition and difference, that is nothing but subtraction. Okay. So addition is done by adding the corresponding elements of two matrices. So for example, to understand this, so here you can write corresponding elements of matrices are added. Same thing here, corresponding elements of matrices are subtracted. Very similar. Alright, so we'll take one small example here. So matrix, let matrix A equal to 2, 1, 0, 4 plus matrix B equals minus 1, 3, 4, 1. This will give us what, students? Okay, corresponding elements must be added up. 2 plus of minus. So what is plus of minus? Yes, it is minus. 2 minus 1 is equal to 1. 1 plus 3 is equal to 4. 0 plus 4 is equal to plus 4. 4 plus 1 is equal to 5. Corresponding elements are added and we got the sum of the matrices. Alright. If suppose it is difference of matrices, students, very simple, only the sign is changing here, minus, this is equal to 2 minus of minus 1. So it will become plus, correct? So 2 plus 1 is 3 there. 1 minus 3 minus 2. 0 minus 4 minus 4. 4 minus 1, 3. What is this? Difference of two matrices. What is this? Sum of two matrices. How do we add or subtract the matrices? The corresponding elements must be added and subtracted. So we'll be getting the sum and difference of matrices. So these both are done. Addition of matrix and difference of matrix. Next, what do we have? Multiplication of a matrix by a scalar. So what is a scalar, students? Scalar is a quantity which is having only magnitude and no direction. Understand? Okay. So for example, same matrix will take 2, 1, 0, 4. So matrix A equals 2, 1, 0, 4. Okay. What is scalar multiplication of matrix? That is nothing but K dot A. What is this K, students? This K is a scalar. Means it is any constant, either positive or negative. Okay. So what is K dot A? K dot A is written as K of 2, 1, 0, 4, which is equal to 2K, K, 0 and 4K. Understanding? So scalar multiplication of matrix means, so a constant multiplied with the matrix, this constant get multiplied with each and every element of this matrix. Now for example, let us take a value assigned for this K. So let us assume K is equal to 3. So 3A is written as 6, 3, 0, 12. This K also can be in terms of what? Fractions. So for example, we'll change the color. Okay, so for example, let us take K equals 1 by 7. So this again can be written as what? 1 by 7 of 2, 1, 0, 4. This is equal to 2 by 7, 1 by 7, 0 and 4 by 7. 0 by 7 is 0 only. Okay, scalar multiplication of matrices. So two operations we have saw, to be precise 3. Okay, addition, subtraction and multiplication of matrix by scalar. So this is also done. Very simple, multiplication of matrix by scalar. So scalar is a quantity which is having only magnitude and no direction. So those are only constants. Okay, so that must be multiplied with the matrices with each and every element or entries of a matrix. The next one which we have is multiplication of matrix. So students, this is special. So pay attention. We'll start with multiplication of matrices. So we'll write here. Multiplication of matrices. Let us take two matrices. All right. So A equals 1, 1, 1, 0 and B equals 0, 1, 0, 1. Okay, students. So there are few conditions in this which you have to remember. Okay, if those conditions are satisfying, then only you can multiply the matrices. So there were few conditions in addition and subtraction of matrices also. What is the order here? 2 cross 2. What is the order here? 2 cross 2. Addition and subtraction of matrices is possible only when the order of this matrix and this matrix are same. If the orders are not same of these both matrices, then you cannot add and subtract. Just remember this. Okay. To carry the operations of addition and subtraction, the order of the matrices must be same. But this does not hold good for multiplication of matrices. So then what holds good for multiplication of matrices? So we'll see that. So here what is the order, students? 2 cross 2. And what is the order here? 2 cross 2 as well. So both are same. So students, the conditions which must be satisfied for matrix multiplication to be carried out successfully is these both numbers must be same. See these both numbers. If these both are same, then you can multiply. If these both are not same, then you cannot multiply. Understanding? Okay. So now means what? Number of columns of A should be equal to number of rows of B. If the number of columns of A is equal to the number of rows of B, then what we can do, students? Then only we can multiply. If this is not same, if these both numbers are not same, we cannot multiply. Okay. Another thing here. So if these both are same, we can multiply, right? Then what are these both representing? This and this. These both, what do we have here? 2 cross 2, correct? How did we get this 2? From here. And how did we get this 2? From here. What is this representing? This is representing order of product. Order of product. So after multiplying A and B both, okay, we'll be getting a product, right? So the order of that product is equal to how much? The order of that product is equal to 2 cross 2. Understand? So these are the rules or the criteria to be satisfied or the points to be remembered in matrix multiplication. What is the very first and very important point? The number of columns of matrix A must and should be equal to number of rows of matrix B, then only you can carry out matrix multiplication successfully. Point number 1. Point number 2, the other numbers which are left out. So apart from these both numbers are left out, right? These both numbers represent the order of the product. After multiplying these both matrices, whatever product we get, okay, the order of that product is given by these both numbers. Okay. So how do we, so these are the points to be remembered in matrix multiplication, but how do we multiply matrices? Okay, that is what we are going to see now. So students on the screen, so same example we'll take. We are writing now A into B. Okay, A into B. Now students, for matrix multiplication, how you have to carry out is first row into first column. Understanding? What is first row? 1, 1, first column 0, 0. This multiplied with this. So this is 1 into 0, right inside the bracket, plus this multiplied with this. Again 1 into 0, 1 into 0. Means first row and first column is giving the first element here. So here we'll write first row, first column. First row, first column multiplication is giving us what? The first element in the product of matrices. Okay, next you see. How to get the second element? First row, second column. 1 into 1, 1 into 1 plus this into this. Now this into this. Okay. Again 1 into 1. How did we get the students? First row, second column. So first row, second column is giving us what? The second element in the product of matrices. The second element it is. Okay. Next, how to get the third element? Go to the second row, students. Second row, first column, 1 into 0, 1 into 0 plus 0 into 0. So 0 into 0. What is this, students? Second row, first column. Second row, first column is giving us what? The third element in the product of matrices. So this will be SRFC. So this will become SRSC. Means the second row, second column will give us the fourth element and the last element in the matrix multiplication of the product. So second row, second column, 1 into 1, 0 into 1. 1 into 1 plus 0 into 1. So now solve this. A cross B equal to how much? A cross B will be equal to, so this is becoming 0, 0, 0 here. 1, 1, 2, 0 and 1. What is the order of this matrix? 2 cross 2. The product of the order is 2 cross 2. Where did we come to know that? In the second point here. Correct? So these both are representing the order of the product. Number of columns is equal to the number of rows. First row into first column, first element. First row into second column, second element. Second row into first column, third element. Second row into second column, fourth element. So I have written it here. Okay, you can just make a note of this. So this is how the matrix multiplication is carried out. Rows into columns, corresponding elements again. 1, 0, 1, 0. 1, 1, 1, 1. 1, 0, 0, 0, 1, 1, 0 and 1. Matrix multiplication. Okay. So for example, if the orders are same, now let us take A is equal to is a matrix of 2 cross 3 and B is also is the matrix of 2 cross 3. Can we multiply these both? Check that. The number of columns in A is 3. The number of rows in B is equal to 2. Are they both equal to each other? No. That is why matrix multiplication is not possible. Is addition and subtraction possible? Order is same. Order is same. Yes. Addition and subtraction is possible. Understand? So this is called as what? Matrix multiplication. So we have a very small example on this side. So example, NCERT, find AB if A is equal to 6923 and B is equal to 260798. We have to find what, students? A and B. So just now we saw how to matrix multiply, right? We'll do one small example. Order of this matrix 2 cross 2. Order of this matrix 2 rows 3 columns, so it will be 2 cross 3. Now here, by looking at the orders of matrices, can we multiply them? Can we multiply them? Both are same? Yes, we can multiply. Because the number of columns in A is equal to the number of rows in B, then we can do what, students? Matrix multiplication can be successfully carried out. Now what are the other two numbers here? 2 and 3. So here we'll be getting 2 cross 3. What is this 2 cross 3 representing? This 2 cross 3 is representing the order of the product. Okay. So we already know that the order of the product is 2 cross 3. So we will draw this matrix one. So AB is equal to 2 cross 3. Okay. This is 2 cross 3 matrix. We'll write here 2 cross 3. How did we come to know this? Okay, from these both orders. Now matrix multiplication will do first row into first column. Okay. So we'll just erase that. Okay, now let's continue. 6 into 2, 12. 9 into 7, 9 sevens are 63. So 63 plus 12, how much? 75. Okay, the first element is 75. First row, first column, first element. First row, second column. 6 into 6, 36. 9 into 9, 81. 81 plus 36, 717. Understanding? Next, first row into third column will give us the third element. 6 into 0, 0. 9 8s are 72. Understanding? We have to add them. 6 into 2, 12. 9 into 7, 63. Add them both. 12 and 63 will be getting 75. Same here, same as well as here. Next, second row into first column. 2 2s are 4. 3 7s are 21. 21 plus 4, 25. Students understanding? Okay, next one. 2 6s are 12. 3 9s are 27. 27 plus 12, 39. That is the right answer. Next, 2 zeros are 0. 8 3s are 24, as it is 24. Understanding? So if we have to write something above all these elements, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column. How did we get these elements? We got the elements by multiplying this row and this column respectively. So this is all about what? Matrix multiplication. So again, just a recap, students. Number of columns of first matrix must and should be equal to the number of rows of the second matrix. Then only you can matrix multiply them. And the remaining numbers are representing the order of the product. For addition and subtraction, the orders must and should be same. Okay, that is the only condition for addition and subtraction. Okay, moving on to the next. So we'll just have a summary of whatever we have done today. So basically we started with what? Equality of matrices. So what is equality of matrices? If two matrices are taken, the orders of the two matrices must be equal to each other, as well as the elements of both the matrices must be equal to each other. Then we can term those matrices as what? Both matrices are equal to each other, A equals B. Apart from that, we saw the operations on matrices. Addition of matrix, subtraction of matrix. How is it done? Corresponding elements are added and subtracted. Scalar multiplication of a matrix. How is this done? So a scalar, that is nothing but a constant, which is either a fraction or a whole number, negative or positive. Okay, so that must be multiplied with each and every entry of a matrix. So that is nothing but scalar multiplication of matrix, usually represented by Ka. And finally, what we saw, students, multiplication of matrices. Number of columns of A or the first matrix must and should be equal to number of rows of B. If this condition is satisfying, then only we can multiply. If not, we cannot multiply. All right. So in this class, we have seen equality and operations on matrices. In the upcoming class, we'll be continuing with the next topics of class 12th mathematics. Until then, take care, wear mask, sanitize your hands. I'll see you in the next class very soon, students. Subscribe to Vista's Learning. Thank you.